Well, I think we've got basic code that's working now with this 360-degree servo motor. You can see it's going clockwise at this time, turning clockwise, and that is based on this DHT11 temperature sensor, temperature and humidity. I'm only dealing with temperature here. So I'm going to try and raise this temperature high enough that the code will turn the direction, turn it anti-clockwise. You can see it stopped now as it gets closer to a warm temperature. My finger's on the DHT11, and it will need to get up to a fairly high command in order to go anti-clockwise. .825. Maybe it has to go to 180 command before it reverses direction. And maybe that, nope, here it is. Going anti-clockwise based on the temperature, which I warmed up to 27 degrees. So what I asked ChatGPT to do was write me a program. You can pause the video if you need to actually read what this says. Write me a program using 23 degrees as the cutoff and run the motor one direction above 23 and another direction below 23. This is actually the program right here. As the temperature warms up, oh, and I changed those, I believe I changed the set point. No, it looks like set point's at 23. So what it's doing, what we're trying to do is prove that this type of motor, which costs about $6 and fits the Lego form factor for Technics, and is called a 360-degree servo, we want to find a motor that will plug in with 3 wires directly. And it's important to recognize that this motor comes with this built-in plug, because this motor also comes with a different plug that's called JST. This, I think, is called a DuPont plug. The JST is a white plug and it will not work on this board. It needs to be the DuPont for these pins. So watch out for that when you go to buy a motor. Well, I don't see it here. I'll put a link to this motor in the description of this video. These are called 5x7 rectangles. They've got 5 holes across and 7 holes down. And that mounts on any beam. And that beam snaps into the board. That's what we're trying to accomplish here. That way we can be organized. We're still around 26.4 degrees, and that is running the motor in a certain direction at a certain speed. If I put my ice cube back on the sensor, you'll see the temperature drop. And now the motor is stopped. I believe that's because in the range of 100, there's not enough power to start the motor running. And as it gets down closer to 23 or below 23, this number you can see activates the motor now in the clockwise direction. And the code says as the temperature gets colder, run clockwise faster and faster. These increments are small on temperature. We're now down to 75. Eventually, the motor will begin to speed up in the clockwise direction as that temperature gets lower and lower. Now you can hear it. Pitch is increasing, speed is increasing, temperature is dropping. 17.9, 17.7. The command is running a number lower and lower, which is speeding up our motor. Again, this is code that was written by Chat. I simply copied it and pasted it right into my Arduino. Copy right here. And then paste this. Oh yeah, I need to mention that this library, ESP32 Servo, you've got to find that library in Arduino. You'll go to Tools, you'll go to Manage Libraries, and right here you type in ESP32 Servo. And you can see it's already installed on my program. Right there. Needed DHT also. We used DHT before, so that's already installed. Those two libraries are necessary. So there will be more.